Welcome to this Raspberry Pi line following robot video. As you can see, the Raspberry Pi has got two sensors on the front of the chassis and they're detecting the black line. When one of these sensors detects the black line, it stops one of the motors and then pulls itself back onto track. Now the thing about this project is it's extremely easy to build and very easy to program using Python. It's a lot of fun to make. As I said, very easy to build. So let's get started. Okay, these are all the components you're going to need to build the line following robot car. Now I work in a school and I run the Electronics and Computer Club, and over the years I've built dozens of these little line following robot cars, and I always buy my components because I have to buy lots, because you imagine there's a class for these class for the children. I need lots of this kit, so I always buy my stuff from the robot shop. Now I'll leave a link in the description below if you want to buy your components for them, but they're pretty much available anywhere on the website. If you go for Amazon or eBay, I'm sure you'll find that anywhere, probably cheaper. But anyway, let's start with the chassis. The chassis normally comes with, this is a piece of plastic base with the holes all cut out. I mean, this has been cracked and broken because it's been dropped a few times, but they're easy to fix. You just glue them back together with super glue. Not a problem there. The chassis comes with two motors, two wheels, and a caster for steering the chassis. Now, if you're going to build your robot car just to control it using the arrow keys, forward, back, left and right, then these motors are fine. They're perfect. The problem is, if you want to use them for following a line, they're too fast. I think it's about 92 revolutions per minute that they run at. And if they detect a black line, the time that the motor stopped, because of the gearing, they tend to overrun the line and it makes it really difficult to control. So over the years I've decided I'm not going to use these motors anymore. So these aren't really good for the project we want, so we have to scrap those and use these two motors. You have to buy these separately, unfortunately, once again from the robot shop. These are geared right down to, I think it's about 39, maybe less, 32 revolutions per minute, and these are absolutely perfect for what we need. So we need two of these white motors. Unfortunately, these motors do not fit these wheels, so we have to get rid of the wheels and bring in two new wheels, which will work with these motors. So that's the chassis sorted out. Obviously you're going to need a Raspberry Pi. Any Raspberry Pi will do. I believe this is quite an old one. This is a Raspberry Pi, yes, it's a Raspberry Pi B, but any Raspberry Pi will do. Long as it works wirelessly. Now this is a B, it doesn't have a wireless connector, but I've got a wireless dongle on there. If you buy one a new Raspberry Pis, the 3s or the 4s, that comes integrated. Then we're going to need what is called a motor controller. You can see that. What this does is the two motors fit into the side here, one left and one right, and at the front here you have 4 control pins, and they plug into the Raspberry Pi. And depending on what control pin is high, it will either make one of the motors go forward or back. So that way, by using the 4 control wires, you can maneuver the robot car. We're just going to be using line following, so we're only going in a forward direction. We don't need to worry about reverse. So in this case, we're only going to be using 2 of the pins of the motor controller, and I'll come on to that in a bit more detail in a few minutes. To connect the Raspberry Pi to the motor controller, we're going to need some ribbon cable. You can buy that anywhere. And we're also going to need these little infrared detectors. So we're going to need 2 of them to fit on the front. Now they need to be sitting below the chassis, so you need a standoff. Now I've got these brown standoffs I just had lying around the workshop, which works perfect for me. You can buy standoffs. This one's a bit short, but you can buy longer ones. Or if you take the tube of a cleaning bottle, you know, when you clean your work surface, there's a tube inside. If you take that out and cut that to the required size and use a long bolt, they make excellent standoffs, and I've used them many times myself for different projects. You're going to need a battery pack to drive these motors, because the motors can't be controlled from the Raspberry Pi, because these need 6 volts to run and Raspberry Pi only needs 5 volts. And you're also going to need an external supply for the Raspberry Pi. I've got this little battery bank that you use for mobile phones. That works fine, and a cable to go to it. So a USB cable that plugs into the battery, and the other end goes to the Raspberry Pi. Okay, I think that's about it. What I'm going to do, I'm going to start to build this now. I won't bore you by going through the whole installation, construction process. I'll do a little bit each time, and then I'll stop the video and explain what I'm doing, and we'll proceed that way. Okay, I'll see you in a few seconds. Okay, I've assembled the chassis now. I've put the motors on and the wheels, left and right, and I've also put the battery pack on. So what I'm going to do now, I'm going to assemble the motor controller card, which is called a L298N. Now, let's get a bit closer to the camera. So you have basically a connection on the left side here for the left motor, one for the right motor, and a number of pins here that go to the Raspberry Pi. So what I've done was I just put a bit of blue tack. I mean, if you want to make a more permanent job, then fine, but because I'm basically taking this apart every other week, I find it easier to use blue tack, because the kids build them, they test them out, and then they disassemble them. So it's a lot easier for me if I just have blue tack rather than permanent screws. So I've just stuck that onto the side there. Now the battery pack comes with 2 wires, a red and a black wire. Now you need to solder an additional wire, or twist if you can't solder it. Twist an additional wire onto one end, and the other end needs to be a female connection that goes onto the Raspberry Pi. So take one of your leads from your ribbon cable, and by the way, all the components that I'm using here are listed in the description below and where you can buy them from. Take one of the ribbon cables on the black side, cut off the one end and just have the female end, and solder or twist these 2 bits together. So you've got one red wire and one black wire. So this block here is the power block. So the first one says plus 5 volts, this says plus 12 volts. The other one is ground, and the other one is 5 volts. We're not going to use the 5 volts. We're going to use the plus 12 volts and the ground. Now, when it says plus 12 volts, that means it can take up to 12 volts. It doesn't mean it needs 12 volts. It can take up to 12 volts. Now, we're going to be using 4 1.5 batteries, so that's 6 volts. So that will go into the first connection here. So I'm just going to push this in, make that connection, and then going to take the black or the ground wire, push that into the next connection. Now I've got a circuit diagram I put together here. So what I'm going to do is I'm going to put this in the video. In fact, I'll pause the video now and you can have a look at it. Okay, so what I've done is I've just connected the power wire for the batteries and the ground wire for the batteries. Now I'm going to connect the motor, the 2 left and right motor, to the controller itself. So the first connection, black, goes into this terminal point here, and red into this one here. Now, to be honest, because we're we're only driving the motor in one direction, we don't need both of these on, but the motors have got 2 connections to them, so I might as well terminate them keep them out of the way, and the opposite direction for this one. So this is red in here. Sorry if it's hard for you to see, but I'll show you. I'll do a close up in a second. And the last one, black wire, goes in here. Okay, so we've now got our motor control board assembled. So we're having power that will come from the battery to drive the controller board. Depending on which pin goes high, it will drive the left motor forward. If this pin goes high, it will drive the right motor forward. The two pins in the middle are for reverse. In this case, this project, we wouldn't be using that. But if we did, then two more pins will go to the Raspberry Pi, and that will control the reverse of the car. So what I'm going to do now, I'm going to get my Raspberry Pi. I'm going to put some blue tack onto the feet just to keep it in place. Now, if you're going to make your car permanent, then I would suggest that you screw it on. But as I say, I'm building these every week, so yeah, I can just imagine there'll be screws everywhere. I've been using a box of screws every week as well, because they'll be lost every 5 minutes. Okay, so I've just stuck the Raspberry Pi on there. I need to leave these two slight vents here available because they're going to be used for the infrared controllers. Okay, so the next thing I'm going to do is take my two wire ribbon cable. I'm going to connect the yellow to pin 1 and the orange to pin 4. And this side, yellow is going to go to pin 15, which is that one, and orange is going to go to pin 13. Right, once again, I'm going to pause the video and let you look at the diagram, just so you know what I've done. So I've connected yellow to pin 1, orange to pin 4, yellow to pin 15 of the Raspberry Pi, and orange to pin 13 of the Raspberry Pi. Okay, have a look at the diagram. Okay, that's good. So one more thing to do before I finish with this stage. I need to connect the ground wire that we connected to the motor controller. I'm going to put that on pin 6, which is a ground point. There's several ground points on the Raspberry Pi: pin 6, pin 14, pin 20, pin 9 and pin 25. They're all grounds, so you can basically use any one. Okay, I'm going to pause the video now. I'm going to connect these infrareds, and I'll show you how I wire them up. So I'll be back in a few seconds. So as you can see, I've connected to the two infrared sensors to the Raspberry Pi, to the front of it. And if I zoom in, you can see that it's labelled with 3 designations: out, which is the control wire for the Raspberry Pi, VCC, which is the +5 volts, and ground, which is the ground. And same for the other side. So what I'm going to do now, let's move the camera back to overview position. I'm going to connect the sensors to the Raspberry Pi. Now it's going to be difficult for you to see when I'm doing this because my hands are going to be in the way. But what I'll do is, once I've connected all the wires up, I'll put a more detailed diagram up on the screen this time. The other one is okay for putting the motors on, but when it comes to the infrared sensors, that diagram is probably not going to be very useful to you. So I've got a more detailed diagram I'm going to put up next, which will show you clearly how the Raspberry Pi wires to the infrared sensors. Okay, so let's do the left sensor first. So my left sensor, I'm going to do the control wire first, which is going to go to pin 7 of the Raspberry Pi. Pin 7, good. My ground wire is white, so I'm going to put that to pin 9, which is right next door. And the grey wire, which is plus 5 volts, I'm going to put it on pin 4. On the Raspberry Pi, pin 2 and 4 are plus 5 volts, so you can use either of those two. Now let's take the right. So the purple is the control wire. That's going to go to pin 10, which is 2, 4, 6, 8, 10. The white wire can go to 14, or 9. White wire, which is ground, can go to, yeah, put on to 14. So that's what the diagram says. And the grey wire, which is plus 5 volts, can go to pin 2. Okay, so let me just zoom in a little bit so you can see that before I put the diagram on. Probably doesn't really help that much. Okay, let me put the diagram up and you can see exactly what I've just done. Okay, that's pretty much all the wiring done for the Raspberry Pi, so I just need now to connect the batteries and then start coding. So the first thing, let's connect the batteries for the motors. So I'll plug in battery 1, battery 3 and battery 4. What I tend to do, I tend to leave one battery not quite connected, and that becomes my on-off button. But if I do connect it, you'll see it's all working, the red light comes on. But I'll just disconnect one battery, because if I code it up and I make a mistake and the motor and the car suddenly jumps into live and runs off the table, I'll just destroy it. So always leave one battery disconnected till you're really ready to test it properly. The next thing is I've got this USB charger for a mobile phone. I'm just going to use that. So I've got some blue tack. Just going to stick that to the side of the car. Now, it doesn't look very neat, but I'm sure you'll make yours look a lot tidier than mine. Yeah, I'm just rushing now. There we go, connects into the Raspberry Pi, and basically that's ready. Now it's fully assembled. All I need now to do is to code it. So I'm going to jump onto the terminal and start working on that right away. See you in a few seconds. So here I am on the desktop of the Raspberry Pi. So the first thing I'm going to do is go to my menu program, program in, and I'm going to select Genie Programming Editor, which is the preferred IDE I like to use when programming Python on the Raspberry Pi. So the program's opened up, PyBot line following program, and I'll talk you through line by line of how the program works. So the first line to look at is importing the libraries. So you have to import the GPIO library, otherwise you won't be able to address the pins on the Raspberry Pi. The second one is the set mode. Now the Raspberry Pi has two different type of pin configurations. It has what's called channel, or BCM, so that's for Broadcom channel mode, or board, which are the pins in the middle. So for instance, if I was using BCM instead of board configuration and I wanted to connect something to GPIO 10, I would have to use GPIO 10 here, which is actually on pin 19. Now I find that a little bit confusing, especially when you're teaching that to young children, so I always tend to use the board configuration. So in that case, GPIO 10 will connect to pin 10. That makes much more logical sense to me. And GPIO 15 and 13 will connect to 13 and 15 respectively. So that's why I tend to use the board configuration instead of BCM. The next one is turn off channel warnings. Set that to false. What happens is if you interrupt the program prematurely, some pins may still be high, and when you rerun the program it gives you a warning to say some pins are already in use. It doesn't stop the program from running, it just gives you an error message, and I find that a bit annoying, so I turn that off. Next two lines is setting the GPIO pins 13 and 15 to be outputs, and these are the pins that are going to drive the motor. So 13 will drive the right motor and 15 will drive the left motor. So we set them to GPIO out. The next lines deal with the sensors. Now I've set up two variables, one called left sensor, and I've got that equal to 7, and right sensor is equal to 10. So when I go to configure the GPIO pins to be in instead of outputs, these are inputs. Instead of having GPIO.setup 7 GPIO in, I can say left sensor. It just makes it easy to read a little bit later on in the program, and the same for the right sensor. So basically all you're doing is substituting that variable for that number there. Now I've got 4 functions. A function that turns the left motor on and a function that turns the left motor off. And basically all that does is GPIO output pin 15, which is one of the motors, and I set that to 1, which turns it on. If I set it to 0, I say here, that turns it off. So 1 is on, 0 off. I could change that to true and have that false. That would still work. So 1 is on, 0 is off. Same for the right motor. Function says right motor on. GPIO pin 13 1 on. GPIO 13 0 off. And the last function, it turns all the motors off. So I run that to start with just to make sure everything's stopped before we start to run the main programming loop. This is the main programming loop. So the first function is to stop all, as I said earlier on. And this is the this loop here monitors the status of the sensors, the left and right sensors, and depending on what state it's on, it either turns the motors on or off. So let me talk to you a little bit about how the sensors work. So sensors consist of 2 LEDs. One is a transmitter and one is a receiver. So long as the receiver can receive the beam from the transmitter, and it does that by hitting a reflective surface, then the sensor is deemed as being switched on. If the transmitter sends down a beam and the receiver can't see it because it's maybe hitting a black surface, then the sensor is deemed as being switched off. So basically these 4 if statements basically are looking for the conditions of the left and right sensors. So in this first function, if the left sensor is off and the right sensor is off, then turn left motor off and right motor off. If the left sensor is on and the right sensor is on, then turn on both motors, left on, right on. However, if the left sensor is on and the right sensor is off, turn the left motor on and turn the right motor off, and that will have effect of pulling the car back onto track. Likewise, if the left sensor is off and the right sensor is on, turn the left motor off and the right motor on, and that will also have the effect of pulling the car back onto track. So that's the program. Very, very simple. It's only really these 4 commands and these various functions that you need to get the whole thing working. So I think what I'll do now is, now we've got the program installed inside the Raspberry Pi, I'm going to enable it and let's see how it performs. Okay, I put together a test track on my desk using standard black electrical tape. So let's test out the Pi bot, see if it works. I'm going to enable the batteries, take it off its stand, and if it's working correctly, as soon as I put it on the desk, it should start to work, and it does. Now, is it going to follow the line? Yes, it does. So our code is correct, and our wiring is correct as well. Excellent. Now, if you'd like to make one of these, I'm going to leave all the code on GitHub, so you can download it and use it if you want. I'm also going to put the diagrams up on GitHub as well, so you can download those. I'll leave a list of all the components that you're going to need on a slide at the back end of this video, and also in the description below. So that should get you going if you want to make one of these line following robot cars. They are fun. I must admit, when I tell the kids we're going to build one of this robot, they just love it. They really do. So good luck if you go ahead and build one, and take care. Bye for now.